Okay, let's start by going over these PowerPoint presentations. All right. We're going to talk about scripts and variables. When we start with Unity, Unity is based on the concept that you have game objects in your scene, and those game objects consist of different components. Every game object will have a transform component, and we will look at that in one. There's a whole slide for that in one moment. The transform is so important is that there's actually, you can do lowercase g game object dot transform and get to the game object and get the transform information the script is on. We'll talk about that because the object the script is on may not necessarily be the object you want, and conversely, the object that you have is may not necessarily be the object where the script you want is. Put that aside. We'll talk about that. That will come up in a future lecture. But for our purpose right now, we're going to build a single object with the script on it. And for our purposes right now, an entity that we are building is defined by where a script on the root of the object. So, an object could be inherited in a bunch of different objects. Like it could be attached to something that's a world. Game object that we're using is basically a folder type structure. But the object that we want has our player, effectively. For our purposes right now, we're creating two types of entities, a spinning entity and a moving entity. And these are very basic entities to help you understand writing scripts. And that's the first thing. We're just writing some basic code. And there's a technique that we have to go over with code that I have to talk about. So let's start with the scripts and variables. So what is a Unity script? Scripts are components that contain the logic for a given game object. That's the big high-level description. The code is written. The code written is this logic, and each script is a C# class, and that's something that you should be aware of. We are creating new C# classes. We will take advantage of that later on. Some later in this class, and definitely into the Game Simulation 2 class, where definitely that's the first thing we go over is how we take that into our advantage in dramatic ways. I'll tell you right now, this class you will probably hit a wall because we don't take advantage of that as well as we possibly could in this class. So don't feel bad if you start hitting walls. Your script's getting huge and massive. There's things that we're not doing in this class that we will take advantage of in the next class. Again, scripts are written in C# and only C# now. JavaScript is now depreciated. Actually, JavaScript has been removed. There used to be a language called Boo. That's gone too. So that tells you how long I've been using this engine. So scripts are just written in C#. And the fact that we're only using C# makes things much easier. Breakdown on a script. There is 4 things that we're going to look at, and I'm actually going to open up Unity right now. Yeah, I don't care about. Yes, we're not using 6.2, and yes, the next Unite, which is Unity's conference, is in Barcelona in November. Hooray. There we go. For our purposes, I'm going to go to my assets, and I'm just going to make a new folder. I'm just going to call it Lab 02 for our purposes for right now. And I'm just going to create a new scene. And I'm just going to do a basic scene. again, I'm going to go to my common assets, and then there is under prototype prefabs, there's a gray floor. I'm just going to drop that in at 0, 0, 0. Hooray, I have a floor. And I'm going to...
Your ice didn't change.
What was that?
Your ice didn't change on the position.
Oh, that's interesting. There we go. Thank you. So now I've got a 0. So the floor is basically designed to be like just be in place. In theory, if I wanted to be this, do I have it? I think I gotta put this at negative 0.05 to get it in the correct place specifically. So, hooray! This is my world. This is all I need. I'm not gonna worry about the game view at all. Actually, I will at some point. Let's go back to my scene. Let's take the main camera, and I'm just gonna move this up 10 and over by 10, and I think 45 degrees. Be negative 45. And I need to go 45, 30. There we go. So I've got, basically I'm just putting my camera in a position where I can be like, hey, I can see things. We will probably jump back to our scene view a lot, but all right, I'm gonna go back to the Labo2 folder now, and I'm going to basically file save this, save as Labo2, and I'm gonna call it Labo2. So this is gonna be my scene file. Hooray, this is all you need to do to set up for your project. And I'm gonna update the lab to, I'm gonna probably pull out the lab document and bring it in just in line in the project to clean it up. That will be after this class, so don't worry about it right now. I'm also gonna create my first script, and it's gonna be mono behavior script. Once upon a time, mono behavior Mono is a competitor, was another technology similar to basically if you wanted to write C# but not use Microsoft, you use Mono. Hooray. That's gone away, but it's still considered, it's still called mono behavior because that's the name of the class. And to rename that would be, oh God, so much work, not worth it. So this is this is Unity's really first major technology debt that it has. When you talk about technology debt, it's a decision that we made years and years ago that we have to deal with now today still. Hooray. And that creates this file. I'm going to call this is going to be my spin script. I'm going to do one more. I'm going to create the other one. I'm going to do the move script. And here we go. All right. I'm going to open up the spin script. So before we do something, I'm going to show you one thing. Go to Edit. Go to Preferences. Go to External Tools. And make sure you're opening via Visual Studio. If you look right here, if it's set by file extension, it's not going to do you any favors. You open it by Visual Studio instead. Make sure this is set. When you open by file extension, it only opening the file. And when you open it with Visual Studio, you're opening the file, but in context of a project. And that will give you the correct syntax highlighting that you want. So I'll point that out in one moment. So now that I know that's correct, I'm just going to open up the spin script. So it's going to bring up Visual Studio. I'm going to allow this. All right. So there are a couple things that I'm talking so the slide basically is pointing out two things right now, how this is structured. First is this using section right now. And for our purposes, using Unity Engine is all that we need. You'll see some older ones, system and system.collections.generic are the two that we'll talk about. But particularly we're using Unity's There's a package. So Unity Engine is a package of code. And when we talk about a package, we're talking about a unit of code that has other classes and things already pre-written, or things that we can write code into. We can create our own namespaces and create our own packages. But right now, for our purposes right now, to start off, we need the Unity Engine package for everything that's Unity related. As we go on, there'll be other packages that we'll use. There'll be other things that we'll add, and there'll be sub packages of the Unity Engine that we'll use. For example, later on, using Unity Engine.ai. Later on, we'll use UI is another one. Another package we'll be using pretty quickly would be TextMesh Pro. So we'll be using more things as well. The one thing I want you to be wary about with Visual Studio is that it might try and be helpful and start adding packages that you think you might be using. If you start seeing rogue things up there and they're grayed out, take them out. They're probably not, Visual Studio probably added them for whatever reason, and it's they're not useful to you, and they're adding, it's going to cause problems later on because Visual Studio and Unity think you're using things that you're not actually using. It's basically what it amounts to. So the next thing, you may see something like a namespace. I'm just going to call it stuff for right now. You may see something like a namespace show up, and that's basically saying this code belongs to this package. We're not going to use namespace for right now, and so basically your script's going to be in the default namespace. So don't worry too much. This is a code piece that we'll talk more about later on. So don't worry about putting things in namespaces. But the next line is this one right here, is this public class spin script : model behavior. All right, public class. Basically, it means you're setting up a class and it can be accessed by other classes. That's all that this means right now. Spin script is the name of the class. For your sanity purpose, the name of the class needs to match the file name of the class. So spinscript.cs, spin script should be the name. The colon here means we are inheriting something. In this case, we're inheriting from the model behavior class. We're basically saying that this basically right here says this is a C# script for Unity. And that's all you need to understand right now. If you take out that colon model behavior, then you are a generic C# class. Doesn't mean you can't use those. It's just you can't attach it to an object anymore. So a script you can attach to an object without its C# classes by themselves can't be, by definition, attached to. We'll talk. There will be times where you'll create generic C# classes, and you can write generic C# code if you want to. But that's not the scope of what we're looking at right now. I'm going to take out what's inside right now. So from this colon down to this colon right here is basically the code is a code block. So a code block basically is any of these squirrely braces will be a code block. And there's different types of code blocks. Class definition is the first code block you're dealing with. Function definition is a code block. If statements, when we get to them later on, will have their code block, and there'll be other code blocks. But the basically right now is that from here down here defines what's in a class. A class in C# is essentially the prototype. It is, or the blueprint for what we create. What we create from them are objects. Objects are instances of class. So you can have, so think of the blueprint as the structure that defines what the class is, and objects are instances of those classes. So we can have 5 instances of the same class. We could have multiple. We could have thousands of instances of the same class if we need to. We will later on learn a structure called the singleton, which is defined by we only have one of these at any given time. We'll talk about that later on, but think of it as that the key phrase is that an object is an instance of a class. When we put the script onto a game object, when the game runs, we will have an instance of that script on that game object. When we work with references to other game objects with scripts, we're working with the reference to the script object. I know this is a bit obtuse right now. This will make more sense as we go on. So inside the script, we can then add things. So we talked about inheritance. Inheritance is a relationship. So this basically says this is a script. But what we're going to do is composition. We can have things. And one of the things that we are going to do is we'll make a variable called a vector, and it'll be a vector 3. So there's other vectors. Let me go. There's a vector 2, a vector 4. So vector 2 is basically 2Ds. Points, for example, would be stored as a vector 2. There is a point class. We'll talk about that another time. Vector 3 is 3D stuff, X, Y, Z. Vector 4 is kind of the underneath of the hood. Underneath is the structure underneath the hood for quaternions. This is our rotation. We'll talk about quaternions in a little bit in a moment. Yeah. So for our purposes, we want a vector 3. And this is going to be our spin control. And I'm just, for the sake of argument, I'm going to set it to vector 3.0. We'll come back to this one second. So we've just added something to the class. This is a member. So when we add things to a class, they become members of the class. The two biggest things you're going to add right now are variables, which are members, and then methods, which are essentially functions. So if I bring back the code that I had here, I have a function called start and a function called update. We'll come over this one more time. So with variables, in order to make these part of the class and make them editable in the editor, we will make them public. Now, there's other ways to do this, but we're going to start with the simplest right now, and we'll talk about the other method later on. So when I save this, I now have a script that has a variable that I can edit in the editor. It's called spin control. Now, let's talk about naming just quickly. Variables and properties, which are they act like variables, you will name them with a lowercase variable. Class names and functions and methods, you will use uppercase, start with an uppercase. Question?
With that, you have spin, and then you have the C for control.
Yep, we'll talk. This is camel case. So we're talking about the first letter. Every word after, so we use what's called camel case. So the first letter, so with the exception of the first letter basically indicates whether we're dealing with a variable or we're dealing with a class or a function or a method. Capital letters, classes and functions. Lowercase, variables. Every word after that will be capitalized. So lowercase for then capital letter after that. Spin script, capital S in the spin, capital S in script. So we'll talk. I know there's a slide somewhere in there, but this is basically how things will get structured. There's two methods here that we are concerned about, that are most important for our scripts at the moment. The start function is a method that gets called when the scene starts. When this object is activated, it gets called start. Update is the method that gets called on every tick. and we're going to use update. So for our purposes, I'm going to make, and so what are some of the type varies you're going to use? There will be public int. Just go index equals 0. So when I'm doing this, I'm assigning a default value to the variable. So in this case, I'm using vector3.0. This basically is giving a vector of 3000. The other one you might use would be vector3.1, which will give you a 111 across the board. There are a couple others. I'll just go to vector3. Let me go right here just to show you. So there is up, there's down, there is left, right, forward, back. So these all have, so there are 3 variables, x, y, z. They could either, so if one of them has a 1 or -1, that gives us our 6 degrees of control. Up, down, left, right, forward, back. In Unity, left and right is negative. Left is -1 on the x, right is 1 on the x. Up and down is on the y-axis in Unity. So up is 1, on y is 1, down is y is -1, and then forward and back is on the z-axis. Forward is a 1 on that axis, and -1 is back. Now these are within our the global axis. We will have we'll eventually get to references to forward, up, and right relative to the game object that we're working with, and we'll deal with that later on. So for my purposes, I'm just going to make sure this is back to 0 again. But we have integers, public, float. These are float, number 9.1, float. There is the double. Why is it yelling about the double? Oh, sorry. There we go. So, sorry, it should be public. Again, we're using the keyword public. It indicates that this is a public variable. This will allow us, other classes, to access it and allow us to edit it in the editor. Again, there will be another way. Another lecture will go over another way that's a little more sophisticated and there's more stuff you have to write. But for right now, we're going to start with things being public because it'll be easy to access this way. So float, public, string, I'll call it message. So one other thing, and then again, we'll do a public character, CAR. And this is basically a single, like a single character. So we'll just do like 8. Let's call it letter right now. So when we're dealing with variables, there is a scope operator. Now we can leave this off. If we leave it off, the variable comes with is default to what's called private. It's equivalent, basically, it's equivalent to putting private in. And I'm actually going to make this private just to show you this. So the two scopes that you're going to be using right now is public and private. There's a third one called protected that deals with inheritance. Don't worry about that right now. We'll deal with that another time, another day. So you'll see that this character letter won't be editable in the editor. Whereas the string is, and the big thing is a string is basically has double quotes. The character has single quotes. Take out that W. There we go. String dot character.
Quotation, single quotation.
Yeah, double quotations means is something in double quotations is a string. Something in a single letter in single quotes is a character. Now, the string is actually a complex object, really underneath the hood. It's actually an array of characters in some way, depending on how it's implemented. But it's become C# and Java has string as a has the string as a primitive in this way to make your life easier. And it's gotten so popular. C# has actually the newest versions, latest like from 2011 on. C# actually now has this implemented to make your life easier. So the other type that I want to bring in right now is a public bool has swagger, and I'm just being funny with my names and declarations. So Boolean is basically it's either true or false. When you hear the term Boolean, it means it either is true or false, or it will resolve down to true or false. These are the primitives that you're going to be using over and over. Vector 3 is going to be one of the primitives you're going to. No, I'm sorry. So there's what's called structures, and there are data types of that consist of other types, effectively. When we talk about type, vector 3 is a type. The integer is a type. Float is a type. So your variables are defined by the type that they are. We'll talk about how to move between. You won't be using double very much. In fact, I'm going to make this private just because we're not going to affect that in the editor. You'll be using float more than double. Just know that double is basically it's a larger version of the float. The thing that you need to be aware about is that when you use a decimal point, it defaults to double in C#. And whereas when you're dealing with a floating point and you want to make sure it's a float, you put the F on the end of it. I think you use D for double is the way to say that this floating point specifically is a double when you're handwriting it. But you'll see 9.1 F, like some decimal point dot, number dot something F, means that this is a floating point, not a double. And so if you get an error saying, I can't shove the double into the float, put an F on the end of it. That's the error that you'll see regularly over and over. In fact, let me take away that F. I'll save it. It's like literal type double cannot be implicitly converted to type float. And they're saying use the suffix X to make little. So it's telling you to use the F. There we go. Thank you, Visual Studio. So that's showing Visual Studio will throw errors at you, and it's your job to start trying to read those. Now, don't get me wrong. It is an arcane language to understand, and some errors make no sense when you deal with them. That's understandable. But you will encounter several errors over and over. Look at what they're saying. So we've got the scope operator, the type, and then the name of the variable. And the name of the variable is how I will use it in my code. So if I wanted to refer to index later on, I will then use the variable name index. The equal signs means I'm assigning something, and then after that is the value. And so essentially, with primitives, you really want to assign them a value, some sort of default value. You can, I can leave, I can do, this is perfectly, if I take out this right here, this is perfectly fine. It means that I will have an empty string when I start with it.
Does that mean that you would still be able to edit it?
I can still edit it in the editor because I made it public. But it basically is it's going to start, basically a string is going to start with no data. I think an index will start at 0, like an integer will start at 0, same with a float and a double. I don't know what I'll get for a character, and I think Boolean starts as a false if I don't. But in terms of good coding practices, These primitives, again, int, floats, double strings, character bools. These should be defined with a value. Structures should be defined. Should be, not always. But like the vector3, I always assign that to a vector. I always say I want that to be a vector3 0. Or I want this to be a vector3 1. Or some other value that I want. For the most part. The vector3, so one of the things about classes is that there is what we call the dot operator. And the dot operator gets us access to members of the class. Now, so vector3.0 in the global sense of the class, there is something that's been set where I can go to the class and reference that property. This is a global property on the class. We'll talk about that later on. There's a way we set that up, and it's called static. We're not going to play with that right now. But basically, we can set properties and methods and members that we can access via the class. We'll talk about that in October. That will come up again in October. So don't worry about it right now. I'm seeding that we can do this, and I'm showing you that there are properties that we'll be able to access that are specific to the class itself. All right. Let's just go back and make sure that we do have our this right here, and I'm going to go in and I'm going to show you a line of code. Just to note that the end of each line of code is a semicolon. So, what does a class include? It includes the class script has the definite. This is how we define the class. It's code block. And then inside the code block, we have members, variables that we can add to the class, and functions that we can add to the class. These are specifically Unity functions. Start and update are Unity functions. They are defined, and Unity will use these functions. So we're going to write something to the console log. We will use debug.log. Now go back and we can do errors, we can do a warning, there's all sorts of different log stuff here we can do. For our purposes, we're just going to use log, and inside it's looking for a string. Object message, it's a string. And for our purposes, we are going to provide it message, which is this string right here. And you'll see that a lot of times we will create a variable, a string that in our function, and then build the string. And I find that building a string and handing it to this function is easier than trying to shove everything. I mean, we could go and be like, we could just give it a string. It's possible, and it's. I tend to prefer to build a variable, and then use that variable to submit to what we want. I'm going to show you the first thing. Now, we're actually not going to use this line of code. I'm going to use what's called a comment, and we'll comment this out. So the first is a double slash on a single line that will comment out that line of code. If we needed a bigger block of code, we use what's called the star. There we go. Visual Studio is trying to give me stars, but this is, let me get a block of text. Class contents. There we go. I'm just going to grab all of this right here. Okay, so this is a block content. So we start with a slash star, and then and then it ends with a star slash. And I've just thrown in more code stuff here to show you that this is a block. So I'm going to save this. So now that I've saved this, so basically I can go back to, let's go back to Unity right now. And I'm just really going to create a cube. And I'm going to set this at 1, 0. So it's going to be floating. That's fine. And I'm going to go to my crayon colors, and I'll make this orange. And to make our lives easier to see, I'll use this green yellow as my grass. Or I can do a cube of grass. There we go. So I'll have orange cubes for my purpose right now. And so I'm going to go back to my Lab 2 folder. Here is my spin script. I'm basically going to grab it. Now I can go and put it on the object this way, here in the scene view. Not a great way to do it, because you could be like, oops, I did it over on this object instead. You can go and do it here in the hierarchy. One way to go doing it. Or I can bring it down here into the inspector panel. I prefer the inspector panel, because I am on the object I want. I am not, and there's not a chance I might put it on the wrong object here or in here. There's three ways to do this. I prefer this way. The other ways do exist, and you might see me do it in a rush. But most time I will go to the inspector. And you can see right here, everything that I've made public. This is not Hello World. Trying to think. Trying to think what's meme worthy right now. Any big phrase in the memes right now that I should be aware about?
No, honestly.
What was that?
I said no, honestly.
No.
I was saying we're in a downtime right now, kind of.
Yeah.
The next big one hasn't started yet.
What was the last big one? I'll just type for Super Earth.
Yeah, just put it on Xbox. That's fine.
Yeah, that's relevant enough for Super Earth. So there we go. I do play Helldivers. I haven't played it in a little while, but I should. But it's been since the Super Earth campaign. Yeah. I needed to take a break after that. That was crazy and stressful. But anyways, back here, I'm gonna go to, so when we press play, so just to operate the game, to simulate it, we'll press play. We can pause it, and we can use when we pause it, we can use the step operator to do frame by frame operation if we want to. I'll press play. And then you'll see down here that you can see for Super Earth, that's the last message. We go to the console, and then we can see there's the message. And this is, hey, I can change... and that's Unserian as a bloodsucker. Yes, he is a vampire, so that is correct. That's a Baldur's Gate 3 reference. So you can see right here that then, I press play, and then here is it changed the log. So let's stop right here. So one of the things that it's doing is clearing on play, on build, on recompile. So you can turn these off. So if I want to see messages from I play, make a change, play again, and see A, B, you turn off these. Collapse. We haven't got to a scenario where collapse. Basically, you've got several messages of the same thing over and over. You can collapse it, and there will be a counter over here. In fact, let's jump in. In fact, we'll move this line of code from start down to update. So every tick, it's going to send out that message. And you can see, hey, and if I collapse, I'm going to get that one message over, and this is going to be a value that's just going to go up. And because again, we're doing 60 frames a second, actually doing faster than 60 frames, but we're going to get this over and over tons of time. So I'm going to stop. I'm going to put this back. I'm going to take out all this other code because this is basically in the way. I just wanted, yeah, let me actually do one. Let me go in, and this is going to be, I'm going to create a new model behavior, and this is going to be the Skunkworks. Call it Skunkworks stuff. So I'm going to go in here. I'm going to copy everything that's inside this. I'm going to do that. I'm going to copy it, and I'm just going to paste this all into here. Because I don't need everything in this. This is so I can just shove this out of the way. Because basically, I'm going to take all of this all out. I'm going to take this comment out because we don't need it. Everything in here, I'm going to take out because we don't need it. Actually, I can actually take out the start function because we're not going to use it. And then I'm going to just keep the update here. All right. So I'm basically cleaning this script up so that what we want for this script, its purpose, isn't obscured by all the stuff that I wanted to demonstrate in here for you. So, all right. Let's go back to, so we talked about class contents. We talked about the class declaration, what is inherent about, and its contents. Again, variables and methods are the ones that we're dealing with right now. There'll be other things that we'll add to the class. There's other things we can add to the class. I mentioned a property. That's one way we can go. There are delegates, and there's other things that we can add to the class as well. So but those we'll deal with later on. We talked about primitive types and what those literals are. I gotta change this. Creating a variable, again, we want the accessibility level, the scope, its type, its name. Again, we want to send the value, and then we do want to terminate the line. In C#, you need to terminate your lines of code. There are cases where we won't. If statements, while statements, those don't get terminated. But for the most part, like we're calling a line of code that you'll see, for the most part, you'll use that semicolon. Again, there'll be a few cases where we won't, but we'll get that later on. Accessibility, again, we talked about private, public, and protected. Don't worry about protected. And then declaration and initiation examples. Class type variables. So in Visual Studio, let's go talk a look. You can see right here that this is has more green color. It's a darker green as opposed to this vector 3 being a lighter green. That indicates that lighter green indicates this is a structure. That darker green indicates this is a class. Technically, the variable, so public and protected, private, protected, class, using these are all keywords, so they come up blue. The primitive variables are coming up blue as essentially as keywords. True and false. So let's go. I like these swagger. And again, let's make this. So the other keyword is true. So true and false are keywords. You can't name things that are keywords. So you can't make a float that is named float. You can't name a double that is double. So these are words that are reserved, and there's a lot more, but you will learn these over time. So don't worry about the whole mess of keywords. These are the ones you need to know right now. When you create a variable inside a function, so we'll do an integer int index value. We'll set that to 0. Index value plus plus. So I'm just going to increment it. And basically right now I have created a integer that's local to this function. It only exists in that function. If you have any idea that you might use it in another function, or you want to access it from another class or edit in the editor, you will write it up here in this section right here. And again, we can put things all over the place. Right now I'm basically saying, hey, this first section is going to be class variables, members of the class. Start and update are going to be your core Unity functions. They will come next. Later on, in I think 2 weeks, you'll write more. Is it 2 weeks? Is it next week? 2 weeks. You'll write your own. Start writing your own functions. They will come down below here. So after update. In theory, I could throw, this, grab that, and I could put that down here. C# will let you do it. Don't do that. This makes your code harder to manage and read. Bottom line, that's basically what. I mean, there might be someone who's like, there's a reason why you should do that. Edge case, thank you very much. Put that aside. That's not, you are not concerned about those edge cases right now. One of the things, again, I should point out, when you open up a code block, this next piece of code that's part of it is indented. And if you look right here, I'm going to just, I'll go back to, let me just grab this line of, let me put this, let me bring back the start. Let's go, we'll do this here. And then we'll do a public string message is equal to if you know the reference I'm making, I'm showing my age. I'm showing my age. Okay. So basically, again, you can see right here, these were all indented. I made a new code block. So functions by definition are a code block. This got indented even more. If you're having issues with indentation, there's a cool feature. So I'll put that over here. I can delete this last and retype it, and it will fix my code for me. If my code's okay, it will fix the indentation for me. I will do this again, just specifically here for this function. You can see it fixed my indentation. Indentation is your friend. It's going to help you keep things in order. Right now, keep these code blocks, these curly braces on their own line. This is a style. This is the .NET style of writing code. And it's very user-friendly. It's longer, it has more lines of code, but it's more, where you are right now as a programmer, it's user-friendly. It's easier to read. There are other styles. It's okay, you will learn them over time. Use them and understand them as they come up. And it will be documented for your project, by your team, how you should do things. Eventually, later on, the code style. There's a code style where you put the first. The example is you put the first right here. Yay! You save a line of code. It's a style. I don't like it. I'll be honest with you. I don't like that style, and I will push you to stay with the .NET style. You can make Visual Studio work in that way, where it will enforce that other style, but I'm not going to show it to you because it's not. No, you should be writing this particular style. I'm going to enforce this style on you because it will help understand where your code is. It'll help you understand and read your code. That's the big thing. I mean, you can see the line, like there's like Visual Studio gives you this nice line. But this is, hey, this goes from here all the way down here. This function goes from here all the way down here. In fact, I can collapse this. I can collapse this too. I can collapse the whole class if I want to. And it shows that ... there's more code here. So there are features here in Visual Studio that are effective that you can use. Class type variables. All right, class types. The one that we will show up this week, let me save everything. And let's jump to, back to Unity. Let's go to the move script. The one variable that I'm going to show you this week is the transform. I use transf as the variable name. You will see that I am not going to establish, I'm not going to assign this right away because objects have to be, your project has to be in an operating state in order to have a reference to it. So down here, I will assign that, I will assign it transf is equal to transform. There is a property of transform. There's also lowercase game object. So lowercase game object is a property that refers to the game object the script is on. I am now saying to the object, what is your transform property? And that will, from here, again, I'm going to use, in fact, I'll just do TF. So this is, okay, we'll talk about this for a moment. I just did a 2-letter variable name. This is lazy coding. We'll be honest with you. This is lazy coding. It will work for our purposes right now, but typically you would want to name out your variable names because it makes it easier to read, make it easier to understand. For right now, I'm going to use TF and I'm going to get away with it. You'll see some other shortcuts. What you need to name variables will be defined by your team by your guide. The one that I don't want to delete that. There is a type called rigid body, and you can see that I will use RB for it. Rigid body relates to anything related to the physics system, basically. And we'll come back to the rigid body in a few weeks. Right now, I'm going to show you how to move things basically using the transform by position. Later on, we will learn another method where we will move objects based on the rigid body instead. So we'll use the physics system. And there's a reason we'll move to that. I'm going to leave this out for right now, just we're not. And I can basically down here say, hey, there is transform. There is a translate function. We're not going to use this because this is relative to the object and how it's rotated. We're not going to deal with how the object is rotated. I'm showing you this so that you know that it exists, but we'll get back to this later on. Let me get back, but I just want to say transform is an object. Rigid body is an object type. Scripts are objects. Scripts are classes, and when we run the editor, those classes become object references on the script. They're object references on the game object itself. So, this will take your time. Don't feel worried. Don't worry too much about it. Over time, you'll get the understanding. This is a class. This is a structure. This is a primitive. You'll work with that over time. Don't worry about getting the differences right away right now. We talked about class variable comments. I showed you that already. Arithmetic. We'll go over this again next week. Plus also can combine strings. So hello world. Now the thing about this is that we won't get a space. You'll get hello world as one big hello world with no space. You can subtract, you can multiply, there's dividing, there's modular, this is in integer math. So divide is weird. If you're using integers, you'll get only the whole number. So 7 divided by 3 gives you 2. Because the remainder of 1, it gets thrown away. Now you do 7 modulus 3, you get the remainder. You get the 1. This will be useful later on when we're talking about going from we're looking at like a texture, or we're looking at a board, like a 10 by 10 board. We can store that as 10 by 10 means there's 100 elements. We can store that in a single dimensional array of 100 elements. We'll come back to that another time. But these are your basic arithmetic operators. Assignment equals sign, plus equals, minus equals. So that means basically multiply and divide by equal. These are equivalent. So speed plus equals 5 means is equal to speed plus 5. Plus 1 minus is the increment and decorator operators. So there are 2 versions of it. One that goes before the variable and one that goes after it. It's rare that you need to use the one that goes like plus x. You will always see x plus plus. It is very rare you need to use that other version. And go look it up. This is edge case work, where you need to use the one that increments before and the one that increments after. It's a small syntactical difference, but functionally you functionally don't use the plus x version. You'll use x plus plus. There's a couple more. Yeah, there's more things I will show. Yeah, this is the end of these slides. We'll talk about mathematical operations like greater than or equal than or equals to. That's next week. So I'm just basically showing you basic mathematical operations. All right. Come to object variant. We'll talk about the transform quickly. So component scripting and transform components. So dot operators, members, dealing with properties, why IntelliSense is awesome. IntelliSense is not AI. All right, well, we're going to put this aside. It's a tool, but it's not generative AI. The Copilot stuff and stuff, that code suggestion stuff, not always great, getting in the way sometimes. On the other hand, IntelliSense is telling you what's part of something already, and it's a very powerful tool. My coding got much. I code better and faster with IntelliSense.
Basically, like a librarian that knows where.
Pretty, yeah, it is very much. That's a very descriptive. It's very much a librarian. It's great in C#. It's okay in C++. It could be better in C++. I'll tell you right now, Unreal does some stupid stuff with C++ that makes IntelliSense harder to use, which is not IntelliSense's fault. So, anyways, let's get back to C#. Dot operator. So dot operator means access members of a reference. Can also use with a namespace to access its contents. And using the dot operator, so hitting dot will bring up IntelliSense in Visual Studio. One of the things that's great with C++, I'll tell you right now with IntelliSense, if you hit the dot operator and you're supposed to use the arrow operator, it will transform the dot to the arrow operator for you. These slides are all on Canvas, so you don't have to take pictures. Just so you know. And IntelliSense is a tool that helps you see what is available to you. It's again the librarian. What's up? Yeah, go ahead. Again, what are members? They're fields, constant, methods, properties. We've talked about this a little bit. For more members, fields, constant, methods, and there's more members. Again, these are the ones that you'll use, fields and constants. Constants basically are variables. Let me just go back into the skunkworks just quickly. What do we mean by constant? So we'll say there's the keyword const. We'll do float, and this is going to be pi is equal to 3.114. And this will be f. Yeah, so in this case, I wrote pi in all capital letters. What is it? Const. Trying to think. Int. Ounces in pounds. 16. So one of the what marks a constant that is in all capital letters. It is rare that you have to make a constant variable. When you assign the variable, when you create the variable, you have to initialize it. So this is why you'll see sometimes it will be part of a structure assigned that way, but it's rarely you'll see a class variable. A class variable won't be a constant variable because you can't assign it on the spot. Yeah, that is relative to the object, your application running. So I'm going to just constants, yay, constants. You won't use them very much. I literally, after today, I don't know when the last time I actually used a constant variable or written one without, an actual use. That will probably change in the next few weeks when I do some math and physics stuff for a class I'm teaching next term. So, but here we go. So that's what constant. It's another keyword. You'll use it rarely. You should know what it is. You can go dot after dot after dot. The dot operator can use the successful multiple times. Resolves from left to right. So game object. So we can go game object dot transform dot something that we want to do. In fact, one of the things that we will do. Let's go to the move script. In fact, we will make a vector 3 location. It will be equal to our game object dot transform. Dot position. So here is dot after dot after dot. Game object is the object we're dealing with. Transform is its transform property. So we're going to get that out. And then position is its vector 3 location, world position. Now, vector 3 is what's called a property. And you can see by the wrench, that means that's a property. The issue with the wrench is that sometimes we can get it and sometimes we can set it, but not always at the same time. So one of the things that that you might see is tf dot position plus equal I'll do vector 1, vector 3 dot 1. And it might so it's going to take this. So it's allowing it. There are times where it goes and the Visual Studio is like, you can't set and get this at the same time. That doesn't make any sense for me. And so one of the things, I did not put in the location. There we go. So one of the things that you'll do is you'll grab the position. Like again, for here, this is so there are patterns of what you need to do. And this is one of the patterns, is dealing with a property that you can't set right away. We will get it. We will do what we want. So one of the things that we want to do up here is going to be a public we'll just call it move direction. I'll set this to vector 3.0. sorry, move vector 3, move direction equal to vector 3 dot 0. Okay, I'm going to take this line of code out. And don't worry about those comments. Those are to remind you, like, hey, what these are. Useful for you. I'm just going to take it out for right now. So I'm then going to change so what I'm going to do is my location is going to be equal to my move direction. And I actually need to change this. If I right click and do rename, I can change how it's referred to throughout the entire script. So I can get that lowercase. This is called reflection and I'm blanking on the other name. There's another term for this, and I'm blanking on it, but my apologies. But basically, that will change all references in my script. Location is going to be equal to my I'm going to do plus equals my move direction times, and there's a class called time, and it has a property called delta time. Why is it yelling about this? Oh, I'm adding it. I'm multiply. There we go. And just so that we have an idea of what we're really doing here, I'm going to do this the long way, and I'm going to take out the plus here. I'm going to do location is equal to location plus, and I'm going to do this the long way. So basically, I'm starting with my location and adding the change of direction times how much time has passed. So this is important. This is very, very important, is that you need to, again, given that we're handling this operation ourselves, we have to handle the move. We only want to move as far over time as the portion of the second that delta time. So every tick gives us we potentially have a different delta tick. Right now, Unity is running at 60 frames a second, so it's about 0.012 is delta time. In fact, one of the things that we can do is do a debug.log delta time. Note that I've done and I've used a space after here, so you can see how long delta time is going to be. So again, there's 3 steps. First, we get it into a local variable, we change what that local variable, and then we put it back. So it's literally taking the inverse of this line right here. And again, we are declaring the variable here, so we don't need to do vector 3 location down here. Once we declare it, we can just use the variable as is. Let me go into Unity. Close Unity. I'm going to create a new object in here. It's going to be a 3D object, and I'm going to use I'll use a cylinder. I'll do 2, 1, 0. Yeah, and let's just make this smaller. I'll do 0.5. And I'm going to make this with my console. Go back to my crayons, and I'll make this purple so it stands out. I'll go again to my project. I'll then go to my lab 2 folder, put the move script down here, and it won't move right now because I've got zeros right here. I'll put a 1 on the Z, so I'll move down the Z axis. I'll press play, and you can see that, hey, this is starting to move in that direction. I can make it move, go back to the scene view. You can see right now it's moving on a diagonal. I can give it a -1 and revert the direction. Put these, and I'll stop. Now, the one thing that you'll see that these values reverted back. So as I'm changing variables in the editor, when it's running, when I stop, those changes will revert back. So don't make changes to your scene per se while you're running. This is a quirk of Unity, and it's something that they're improving on, but it's not there yet, really. So. I'm going to make this back to 1. So right now I was only moving at 1 unit per. If I go 10, I'm going to go flying. You can see that. So that's 10 units. So again, we're dealing with over a small area. So big units. 10 is a big unit. 100 would be a much larger unit. Now, if I was dealing with thousands of units in terms of tens of thousands of units, then 10 would be slow. 100 might be more reasonable. But then we're talking about 1,000 units is a kilometer. I hope I've done my math correctly. If not, you can yell at me later on. But be mindful of what your scale. So I've shown you how to do the move script. I've shown you this is a pattern, and this is something I want you to be aware about. You're going to copy literally this code by verbatim this week, but I want you to know that this is a pattern. The last line of code is the most important one in this structure because it's the one that moves the object. So if you don't set the location back to, with the game object transforms that position, then your object won't actually move. So I'm just pointing it out. Again, with TF, anytime what's important here is that I'm going to write this again in a different way. Location is going to be equal to tf.position. And then location is going to be equal to move direction times, again, like how I set up before. And then we can do tf.position is equal to location. I'm just going to put this in a block code. This is so anywhere we have GameObject.transform, we can replace with the variable TF. That's basically what that code, what's going on here. We can create variables that refer to specific things and then use that variable to make our code easier to work with. This is the first one, dealing with the transform. Do we need to? No. If you don't use the TF variable in your code, like mark off points, no. I'm just showing you that you can do this. Later on, we will use, again, particularly with the rigid body, like one of the things is that we'll need that variable. We'll then get it in the start function and then use it everywhere else in the class. So I'm showing this to you because we will use it. Not that we're using it. We need to use it this week, but that we will eventually use it on a regular basis. For the spin script, I'm actually going to go over. So let's talk about the spin script. I'm actually going to use. And again, note that I have not made it public because I'm not going to assign the transform I'm not going to assign in the editor. I'm just going to get that. So there are things that you will assign in the editor, and there'll be things that you will assign by getting it in code. In this case, I'm going to use the transform. In this case, I am going to use the transform variable in this case. Transform. Now, there is a get component. We'll talk. I mean, this is the same thing as TF is equal to game object transform. These two lines of code are equivalent to each other. In fact, oh, hold on. Let me make sure it is. There we go. So these two lines are equivalent to each other. We will see about get component later on when we, again, we'll get other scripts, we'll get cameras, we'll get the rigid body, the material, there's the render, mesh renderer we will eventually get at some point. We can play with that. We can assign materials in code. You will see this later on, and this will come, I think, next week more likely. But I just wanted to make sure that you've seen this. But we're going to assign transform, and this will be transform dot rotation, and it should be a capital R. Sorry, dot rotate. And it's looking for a vector 3 in Euler's. Okay. Euler's mean roll a vector 3. It's basically yaw pitch roll is what we're talking about. Yaw pitch up and down roll left side to side. Yaw is basically which direction am I looking at effectively. That's what Euler angles are. They work, but there are things that go wrong with Euler. There's Euler locking. Basically, when values get to really close to 0, weird things happen. And when things are at 0, things can lock up and not work. In fact, in one of the Apollo missions, there was actually a Euler lock with one of the variables, and the pilot knew exactly what was happening, and basically nudged things to get things back on track. With quaternions, there's 4 values. There's a direction and then a roll, and that fixes that Euler locking issue. But the problem is that it's what mathematicians call proper vector math, and that is way over our heads for what we're dealing with right now. For our purposes, we're going to work with Euler's and have it transform that into Euler effectively. And this is rotation's going to take a vector 3 and basically okay, off we go. And it applies a rotation. So this is going to be essentially our spin control time delta time. And in our case, we've only added 2 lines of code. It would have been 1 if I didn't use the TF variable. I mean 3 with the TF variable, 1 if I did GameObject.transform.rotate. I'll just put in that line of code just so you can see it. GameObject.transform. There looks like there's another version of rotate. It's interesting. So functions, methods can have what's called overloads, and so there's different versions of it. So this one takes taking Euler's. Rotates the object by the axis, so when an axis by an angle. Relative space 2 takes the 3 variables. Yeah, so there's different versions of. We're going to use again the first version, which is basically hey, rotate this by this many degrees. For our purposes, we're going to take our spin control, how much we're going to rotate, and going to multiply. So it's basically going to be a number of degrees per seconds. I'm going to delete that, and I'm going to comment out this line of code. let's just jump into Unity, and we're running out of time. So let's put this spin script on here right now, and there's basically here's the script, this message. Message is not part of the assignment, so don't worry about it. But we're going to rotate on the y-axis, so we're going to rotate around that green axis, and we'll say 45 degrees a second. We'll press play, and you'll see this one will go off in that direction pretty quickly, and you see this is rotating in. And I'm going to move you back down to 1, so we're not going off. Your assignment, so basically I'm going to take, move him forward to, I'll go 4 units. And then I'm going to basically copy and paste. And I'm going to turn on my grid, so copy paste, and I'll put this right here, and I'll make sure that hey, -1, keep you 1, and then I'll do 1. So it'll go off in that direction. This will go off in that direction. This will go off in this direction. And there you go. You can see the scene view that they're going off in their different directions. And this is again, by providing our designers properties and things to assign and set up, we can get different behaviors. I'm going to go in right now. I'm just going to copy. There we go. I'll do -45. We'll keep that, and I'll do 720. Let's go fast. So you can see I've got it's rotating that way, it's rotating this way, and this is rotating pretty fast around this way. This is what I'm looking for in terms of your assignment. I will ask you to set up, show me your that you've set this up. The last thing that we are going to talk about essentially is, hey, how do we set up an object to rotate around a point? Well, we're going to create an empty object, and this is going to be the rotation root. I'm going to set this at 10, 1. So I'll do that 0 and 10. So it will be up over here, will I? And then I'm going to basically add a 3D object, and I'm going to use a sphere. I'm actually going to use 2 spheres for our purposes right now. This will help demonstrate. So for the purpose of this sphere, I'm going to move this out not scale. I'm going to do the position of 5. So let's go to my materials. Crayon. So I'll give this yellow, and I'll make this blue. So effectively, this is the sun, and I'll call this Earth. And I'll move the rotation root up 1 so it's out of the ground. So for my purposes, the rotation root is where I'm going to basically go back to my lab 2. I'm going to put the spin script on here, and I'll do the rotation of I'll do 30. Do a slow rotation, and you'll see that the sun won't. So basically, the idea here is that we have a rotation point that is the rotation, and I am. So one thing that they'll be helpful up here is go put this at pivot rather than center. That will help you more times than not. I'm going to keep this in my global. When you see local, it means if I rotate this, I go back, you can see that now my axes are rotated based on its current rotation. I'm going to put this back because I don't need to actually rotate this right now. Well, I'll leave it. We'll see the axes rotate in real time. So I'm going to go press play. So the idea is that I have this object that's rotating. because this is at 0, 0, 0, it's going to rotate in place. Whereas the Earth here is going to rotate around. It's going to physically move because it's offset by 5 units. And that's how you're going to do most of your rotations. Is you're going to have a key, you'll have one object that is the root for the rotation, and then you'll offset the other object by some certain amount and do the rotation. And that's what we're looking for. You only have to do one version of it. I'll press play. You should be able to see it. There you go. It's going around this way. But yeah, there it goes. You know, we can do some things like move this. Let's select the, rather than be there, we'll just put that there. We can make the sun 3, 3, 3. Oh, that's the root. So by making the root 3 by 3, I scaled everything up. It's not what I wanted. So I wanted to set the sun to be 3, 3, 3. And then we can set the earth, not 5, but we can do like 15 now. We'll do 10. Because I've moved that out, I'm going to just bring this up to 90 degrees, so it's a faster rotation. How fast that object is moving is relative to how big so if I did 360, it's going to do a whole rotation around in 1 second. How big that circle is going to affect, then is going to affect how fast it's moving. So if I made this smaller, it would look much smaller. If I go even further out, it's going to move faster because it's got to keep the circle's getting bigger. The radius of the circle is getting bigger effectively, and that's why. So. But this is what I'm looking for in terms of this assignment. This last piece is about thinking about how to use our scripts in different ways. This is our first applied usage of one of our scripts. Any other questions before I stop the recording?
In the scene, like you were saying, for extra credit, if we did like a solar system, deal with that in a different.
Yeah, do that on a stiff. Do that. Yeah, do that. You could do it in a different scene just for the sake of convenience.
Okay.
The scaling one you could do in here with no issue. I'll give you a hint. I'll show you in the Skunkworks. What you want to be playing with is the game object transform.
You're always doing the dot, right? The dot.
Yep. Game object dot because we're getting members in this case. It's going to be local scale. So there is local position, local rotation, local scale. Typically, when you're dealing with the object itself, you're always dealing with its local scale. And that's just a quirk. There's actually no world scale version of it. But you can write scripts that are where basically you are working in the locals. So what you're saying is that you're assuming that this object is parented to something else automatically. You're going to work within relative to that object. So doors. And I'll be blunt. The Unreal guys next week, this is going to hit you right in the face really quickly. You've got your next week's assignment. You're going to make 2 sliding doors, and you're going to build them on the local scale, not the global scale, for that reason. And we'll talk about that next week. But. And if you were building a door, you'd probably have a root object, and then the door itself would be a subcomponent, and you'd work in the local scale, local position, local scale, local rotation, as opposed to the global, because that will make things easier for you. Like if you decide to rotate the door structure and you need one 45-degree angle, you need a 60-degree angle. The door will always work as you want, opening up as you want based on how the global rotation is. And then you're opening it based on a local rotation. We'll talk more. This is getting really complicated really quickly. It's not something you'll be doing right away. It's something you'll do probably later on in this class. So don't worry about that right now.
For local scale, would we do that by delta time?
Yeah, you do that by delta time as well, because you're like if it was like vector 1, and I wouldn't even, it wouldn't be, it'd be, I would be adding, I'd be adding. This is the case where I'd be adding the current scale vector and adding it by a certain amount over time. And it wouldn't be 1, it'd be maybe 0.1, because you're wanting to scale slowly over time. Because like, I mean, you could do 0.1, but it'd get big really fast, and it would accelerate over time because you're going from 1 to 2, 2 to 3, 3 to 4, 4 to 5, that level. You'd want to slow that down effectively, but that's the variable you'd want to use. Any other questions? Any concerns? All right, I'm going to stop the recording here.